Welcome to the May meeting of the Houston.net Users Group. You're welcome to join us in person for pizza, prizes, and networking on the second Thursday of every month. Our meetings are hosted by Improving Houston in their office at 10111 Richmond Avenue, just inside the Beltway in Houston's West Chase District. You can check us out for meeting notifications at HDNUG.org, on Facebook, or on LinkedIn. And now a word from our sponsor, WSO2. WSO2's products support the agility and innovation you need for a successful digital business. Designed to serve as the core of your digital transformation journey, all products are open source, easy to assemble with other components, and work seamlessly with each other as a single cohesive platform. WSO2's offerings cover API management, integration, identity and access management, and analytics, enabling you to harness the power of the cloud and quickly go to market, extend functionality, and ensure high availability and performance. Check them out at www.wso2.com.
Apologize for that. How's everybody doing tonight?
Good.
Good? All right. So I'm glad I only have like 3 slides. We're going to get through this quick, being that we used up so much time. I'm just kidding. So most of you guys know me. I'm Richard Flores. I am a director of consulting with Improving. I've been in IT for about 15 years, or over 15 years. Not only do I help manage the company, I also am a developer. So I spend time with clients and write software for them. So how I came up, why am I here talking to you about this? So as of late, I've been doing a lot of like DevOps type of work, and I have just been going through a lot of pain dealing with our clients' setup. And not to say is that they're bad people or that they're doing things wrong. Actually, what I'm seeing is just very common, I think, in a lot of places. And so I've been dealing with a lot of friction, and so I've been trying to do my best to reduce that friction. And with that said, I picked up some things along the way out of necessity, and I'd like to share that with you guys. Okay, so we're here to talk about shared databases, right? And so I had initially had a hard time coming up with the title for the talk, right? Because I was just like, this is kind of weird. It's kind of like in 2 places. And I'll show you what I mean about that here in a second. But I was just like, all right, the main thing I can do to help out is share my experience, right? And give you guys some insight into how to avoid sharing databases, right? Which has been one of the main problems that I've been dealing with here as of late. And so along those lines, it's like, okay, well, the database and where it's located at is one thing, but then there's the actual data itself. And so that has been another pain point, because it's just every time it seemed like I went to go do something, it was like, oh, that's just bad data, right? So you end up wasting a lot of time. So we'll talk about that more here. But so I want to start out with a little vignette, if you will. So just to give you an example of kind of the things that I'm talking about. So you're working on an accounting project, right? As a developer, and you're going to do an enhancement for searching journal entries. One of your teammates is also working on a feature, but they're adding additional information to an invoice. Right? And so after your teammate starts working on their feature, they realize that there's some redundant data, and so they want to do some cleanup. They want to do some optimization. So they say, oh, okay, you know what? I'm going to move this column from the invoice lines up to the invoice header. Right? Pretty common thing for people to do as they're working. And so to test the change, your teammate goes ahead and commits the change, updates the database, does his changes, dev side, says, yeah, you know what, I think it's good to go. So they send it off to QA to get QA, and your teammate takes off for lunch early. So you're actually pretty close to wrapping up your feature as well, right? the changes that you're making. And so you start your desk side checks, and you're pretty confident that you're going to get done soon because all your tests are passing. And so you realize, oh, you know what? I need some invoices to test this. Right? So you go to generate the invoices to test your feature, and then you get an exception. Right? The app blows up and tells you that you have an invalid column. And so you don't really understand what's happening because all your tests are passing, and you didn't touch invoices, right? So now you got to start figuring out what's going on. And so you finally decide to look at the table in the database, and you realize that that column that it's complaining about is no longer there. And so by now, everybody's at lunch, right? And you stayed late to try to get this done, and nobody's around. So you stay miserable, waiting for your teammates to get around. Maybe you grab something to eat to find out what happened when they get back from lunch. And so, of course, it's the end of the sprint, right? And your teammate took a longer lunch than usual because he or she got done earlier, right? And so eventually you decide to just refresh your branch, and lo and behold, everything starts to work. Right, but at this point, QA is like, hey, I'll try to get to it, but it's the end of the sprint now. So now you weren't able to get that work in, and you got some carryover for next sprint. So does that scenario sound familiar to anybody here?
Yes. I've never seen that happen.
All right, good. And like I said, I think these are very common, right? And so we want to try to learn from this and see how we deal with it. So what happened here? I mean, your teammate for the invoice didn't conceptually change the invoice. They just moved data from one table to another, right? And when you went to test, I mean, you essentially had the same invoices, right? But what was different was that, yes, conceptually, the invoice was there, but the schema had changed. And so you had not had the opportunity to update your schema or your objects inside your code base to match that schema, and that's what caused a break. So now imagine when this happens at a larger scale, right? When you start integrating other teams or multiple people, and now you got to play this, traffic cop game with the development database because you guys are all stepping on each other, right? And so, like very common, you come in the morning, oh, dev's down for whatever reason, and you're kind of sitting there waiting, and maybe it'll affect me, maybe it doesn't, but there's got to be a way that we could take the pain out of doing this development work around databases. So what my goal is to talk to you guys about some basic rules for database work, managing test data, right, because those go hand in hand, and then we're going to look at how those things have been done traditionally and how they've changed now, with the cloud, right? In particular Azure, and the services that they offer. All right, and then we'll do a summary and answer questions for you guys afterward. All right, so some basic rules for database work. So, by the way, the ideas here are based off of a blog post that I had came across by K. Scott Allen. You guys familiar with him? Ode to Code? Mm-hmm. Right?
What was the name again?
K. Scott Allen. He does Pluralsight videos. He's got a blog, a lot of really good stuff on here. So this blog post was written almost 10 years ago. But even though it was that long ago, I mean, it's still relevant today. So the first rule is don't use a shared database for development work. Now, I tend to be more pragmatic, and like I said, I'm very understanding of circumstances, situations. You only been there for 1 year, and it's been like that for 5 years. I get it. Now, if you venture off to Scott's blog, like he speaks in absolute terms. He's like, never use a shared database, right? And that's great, but how do you deal with that, right?
When you
And
say
so-
shared, are you saying production or shared?
Like shared, so let's say-
So you and I are both using a sandbox database.
Pretty much.
He doesn't like that.
Right, correct.
Okay.
I was thinking even to the extent of like linked databases, to where are they all pointing to the same database instance? Or are you talking about shared schema? Because when you speak cloud, you can have a bunch of different copies of the same schema, and everybody would be working against that. What is shared mean?
Right, so not linked databases, shared, whereas you have more than one person. Like, first of all, most of us are all going to be, you're going to have several people pointing to a database ending normally, right? But normally, you're not updating the schema. So in this case, it's you're doing development work and you are both updating the schema at the same time or near the same time. So that's what I mean by shared.
Okay. Thank you.
And there are some actual valid cases for shared databases, and we'll talk about that.
Thanks.
For sure. Okay, so shared databases they're convenient, right? Because it's a single server to make schema changes and test against, right? Everybody knows where it is.
I think so. Take a copy of the production, copy it over to my sandbox, and it's up to date.
That's it, right? And so that shared server functions as an authoritative source for the database serves for the database, and it also serves as a data repository, right? A shared data repository that we can use to do our development. But despite its conveniences, we want to avoid shared databases because you can easily overwrite others' changes. I mean, that's the bottom line. So the changes that I make on the server breaks the code on your development machine, right? And so we got to play this game where we got to be mindful of that. And so that just wastes time. In addition, having a remote database can be slow, right? And difficult to work with sometimes. So don't use a shared database, like I said, because it could be a waste of time and it can also end up producing bugs. Having a single authoritative source for schema. So we just kind of said that a shared database serves this purpose, right? But that's not the way we actually should be doing it. I said there is a good case for having a shared database, and I'll talk about that here shortly. But you want to keep a single authoritative source for your schema. Ideally, the single source for your schema should be in your source controller. You shouldn't necessarily rely on that database to be that single source.
Plus, when you have a shared database as your authoritative source for schema, when Dev A is making schema changes that are sometimes breaking changes, the whole team has to be held up or make sure that they coordinate the check-in and check-out. It's something of a bitch.
Yeah, definitely.
Yeah, but you can't be making schema changes and the rest of the coders on the database not know these changes are being made. I mean, I've never worked in a situation where everybody didn't know. You know, we always had an authoritative.
Lucky you.
But even if you know, like, you can't control people's actions oftentimes, and
But they can't make changes to schema. They can read
yeah,
it.
exactly. You know what I mean? So, and you know, when it comes to you know, having that single authoritative source, everybody should know where the schema is, right? Should not be a server. You should know that, hey, it's in my source control. It's in my source code repository.
Well, and if you're using code first EF generates the schema.
Right. Yeah, I mean, so I
Well, that's
should
scary.
like using,
I've never used that.
right? So I mean, yeah,
It
using,
actually works quite well.
Yeah,
But it does, but it's,
and that's actually one of the things that you know, like Scott prescribes, right? So ORMs have the capability of doing this. We have some third-party tools that are specific for just managing migrations, and you can also do this with scripts, right? But the bottom line is that you want to take all those things, and they should be in your source control, because instead of going and connecting to a database and bringing that down or copying it, whatever, I should just be able to perhaps integrate that with my build and create a fresh database from my machine, right? Not have to share it with somebody or rely so much on a connection.
I can just give you access to, the database. You make your own. You can install that on your machine, and
Right.
and you can take the production database from last night's backup, and you load it up. You got the latest schema. You got the latest, or
Okay, so I'm gonna go home then, because we're done there. Thank you.
And there's no way that can fail ever, right?
That's actually the idea, though, and that's we're gonna cover that.
I'm
more.
staying with your slide.
No, that's what I'm saying. But that's the idea.
I think many couldn't hear. He's facing that way.
Oh, okay. Well, good thing is I want to cover it anyway.
No, shouldn't developer one have known not to delete stuff in the data schema?
They should,
Okay.
but
that's-
right, but I shouldn't have to
Yeah.
be waiting on you, right? I should just be able to work unimpeded.
There's a lot of things that developers should do and
Yeah.
should know,
Yeah.
right? But the world is as it is, not the way it should be.
Well, we have email.
Yeah, darn.
That's just one problem, right? There's more. All right.
But wait, there's more.
Yeah.
Well, this is a good idea.
So
Always done this.
then the last rule is to version your database, right? So the idea here is that you will propagate changes from your local machine up to development, to staging, and production, all right? And if you have customers, that goes out to your customers.
I've seen people actually version their tables too. So you'll have a table with versions in it, so it has the table name and the version number and the history.
Right,
Of
and
the
now.
changes that have been made, and in the comments, you'll have a field and it'll say what changes were
Right,
made.
and there's tools
Yeah, but
now
only
too
old
that-
guys do that.
Hey, Rich,
What's
And
that?
I know it. I go back
there's
to,
a question period to where we can kind of like just talk about different subjects that are off topic and.
Yeah, absolutely, but no, I'm good. We can roll with it. So, yeah, if you have any questions, yeah, please let me know. I don't mind. But yeah, so there's tools actually that allow you to do that. You can create an actual table with the history. Fluent Migrator's one. Actually, EF does it as well. DBUp is another one. So there's several tools out there that can help you do that. But so essentially, you want to version your database because as you propagate those changes up, if you need to make a change back, right? So let's say you release a bug and something happens and you want to troubleshoot, not necessarily roll back in production, but you want to troubleshoot it and you need to find, okay, hey, we got changes in flight right now. We don't know if we don't think that's it because we haven't released those yet. So what have we released? And so then you would look at what version of software you released, because your schema is going to coincide with the version of your software. That's how you're versioning your database. But that is probably the most important part of this rule, is that you have a way to now determine what schema it is that you have.
Version for development or for them as well?
So think of the version as, so, in most software you might, some companies do it, some companies, or you would use some kind of semantic versioning, right? And so your code has a version, like 1.2.1. Whatever, right? And so when we talk about versioning schema, we're not saying that, the schema is going to have a different version number than the code base, because they're all stored together in a single repository. That schema now has inherited the version of that software base, right? So like when you finally release to production and you tag that, that release with whatever version number it is, that's the version number of the schema that you have, right? And so this assumes that you have some kind of strategy for managing your release branches, and that you can get to it, pull it down, spin it up on the box, do some troubleshooting or whatever, so that you can release a patch, right? So there are a lot of assumptions there, but it's not specifically for an environment, no.
So not like any change is a different version.
Correct, yeah, like, what constitutes a version is your official strategy for releasing. But you can actually, like, any change can be considered a new version, right? But those are iterations, that's not necessarily a version change.
So
So
do
you
you
get-
store the version in the database as well? How do you identify what version the database is?
Yeah, you associate it to your repository.
So it's
to your source
basically
control.
a set of scripts that are checked in that constitute the version.
So there is not the same thing. Like, there are, like I said, some of these tools now that allow you to track history of changes so that you can migrate back and forth with changes that you made, roll those back. That's different. What we're talking about really is more of a logical association of your database schema with your code, with your application's code, right? So because they're stored together, then they're considered to both have the same version.
You can also have your application check the version when it's running and say, oh, I need to stop because this has changed. I can't update this table because I don't know that field.
EF does that for you.
Pardon?
Oh yeah, it'll tell you.
EF does that for you. I'm nervous about EF schema changes. It does that stuff for you. No additional code necessary.
You have multiple applications at a time. Okay.
All right, so
Often you increase the version number.
how often you increase? Well,
What
that's,
stage in the programming?
yeah, I mean, that's a strategy that your organization would have to come up with, but that's really dependent upon your release cycle, right? I mean, some organizations release once a year, some every quarter. So whatever you define as an official release and whatever way of managing the version numbers, I mean, that's how you would get the version of it, right?
You minor version or major version only?
Like, yeah, that's just based, that depends on whatever your, what way it is that you're using to version your software. Right? So that's a different topic in the sense of like how you do it. This is just saying like, hey, this is what you should do, not necessarily how to do that part of it.
I have a visual, right? About the shared database, okay, as long as, let's say so many developers are working, as long as they don't do any DDL, DML, whatever heck anybody can do, that's fine, but as long as you don't change the DDL, you are okay to PCL database at that point.
Right, but what
As
if we
long
need-
as you don't change the table structure, you are okay.
Right.
But the DML, most likely that is you are creating your own still procedure or whatever. But at least nobody has to worry about everybody is reading the same table. As long as column you don't change, no DDL change without talking to others. To me, it should be okay.
See, here's the problem though, is that assumes, one, that you have really good communication and coordination between your team members. It also assumes that they're probably around you. They're not physically located somewhere else. And the other thing is that those are all easier said than done. And we assume in that scenario that the code is written very well and that it is partitioned very well, right? Like you have your domain and you have ways but what we see in the real world is that we have a lot of dependencies, right? And so more often than not, teams have some kind of underlying dependency in their code, and so a change that you make in your code base will inevitably affect me somehow or some way. Just because, like I said, we don't do a good job of separating those concepts when we write our code. And so, there's a lot of assumption that it can work. I'm not saying that it won't, but it's just adding a lot of track. And we'll talk about that a little bit more. in a
That
second.
if somebody creates, say the QA goes ahead and create a suite of test data, and some developer comes in and mutates that screws of their tests.
That's what you have.
So QA is spending time writing test scripts, generating test data, and some developer's program comes and mutates that. Now the QA cannot rely on that, since the QA and the developer are using a shared data.
Yeah, girl, and that's a good point, and we're gonna cover that. So let me move on here. But so basically, with those three rules, right? And they say whenever you use a Venn diagram, that's an automatic sign of genius or being smart, right? Yeah, but the point is that there's a lot of overlap between those rules, right? And here going forward, we're going to be focusing on this area here in the middle. When we start talking about test data and managing test data, because they all kind of are interrelated. All right, so now let's talk about managing testing. All right, so why is data so important in this conversation? We've already touched on the main point, right? Is that if I'm in there making changes, that makes my job harder because I can't depend on that data. So when you're sharing databases, test data is the data that we use to write our code, right, and to test it. And so to test a software application, you need to enter some data and have some existing data as inputs to validate the behavior of your software. And so it's important because that data serves as a known state, right, in order for you to validate calculations, or some other like functions or some other more complicated behavior of the software. And so for us, I mean, obviously we're talking about matter here, not data, but ultimately what we want is our data to be stable, right, reliable. And so we want it to be rigid, have a fixed state, fixed volume, right? We want to know what state it's in, not be all mushy or liquidy, right? Because then that's going to slow us down. So can the quality of our test data affect the results of our testing? Right, it can, right?
Data.
Because if you had missing or incomplete data, then this not only can affect the result of your calculations, but also the behavior of the system in general, right? This is where you start getting into those scenarios where it's like, oh yeah, it's not working. Oh yeah, that's bad data. Sorry about that, right? Yeah, you should try this database. This one has good data. Now you got to go in there and update your configs, right, to change your connection strings and all this stuff. Not only that, you think it could affect your productivity? Right? That was one example right there. If I have to stop what I'm doing now, find another database, change configurations, like that's all stuff that's just slowing me down. It's friction. Right? And so you can spend a lot of time working through those things. So do you think it would be easy or difficult to write an integration test if the data was constantly changing? Almost nearly impossible, right? I mean, unless you had a way to roll back the changes, but if it's a shared database, chances are that, that's not happening. And so what I've seen as common practice too is that oftentimes integration tests are easier, they should be easier to write, right? Because you could just go from the interface and perhaps write a test. But a lot of times people just don't do them because you can't depend on the data that you have, or you have to come up with some way to make sure that that's stable.
Use the initialization script for that, for writing the test that you're going to.
Yes.
Then we can, update that in the source and we're going to have that immediately in the new database installed.
Correct, right. It should be a combination of some kind of scripts, or you should have some way of harvesting that data. I mean, but ultimately, the quality of our test data affects more than our code. I mean, it also affects our productivity. All right, so how can we get stable and predictable data? So traditionally, test data is generated by testers or automation tools, or copying test data from production. Right? That's another very common practice. So we're not going to be talking about like automation tools for testing and generating test data in this talk, but instead we're going to focus on how production data can be captured, right, in order to provide this data that we need to give us that good starting point. So when we're talking about this, we're going to assume that the data is produced either by testers doing some kind of input and then harvesting that data out of whatever it is that they put it in, or taking a copy from production. All right, but we're going to have a file that we're going to start off with. So how can we then manage our test data to achieve this known state now that we know that we want to get it from a single source? So the traditional way of managing data is, starting up here, you would have a database server that we said was filled with either data from users doing some kind of input or taking a copy from production. So in this case, we'll assume that there was a copy made from production. And so we send off a backup of that database to a file server, and then from the file server, our build server pushes that schema to our dev server, perhaps on a nightly basis, right, so that we get a fresh database every morning. And then we might have some scripts sitting on our local machine, but we can go up and grab that backup as well, right, onto our machine and spin up a fresh copy of the database, right? That was based on good data from her. Now, we'll probably in between there somewhere do some sanitizing, right, like maybe masking email addresses or applying some kind of change so that you avoid getting in trouble, or do some kind of compliance that we're required to do. And so when we talked about propagating changes, the changes then propagate up, right? So the idea here is that you start local, goes up to dev, and then from there, as you are approaching the end of your release pipeline, staging, and then production. But notice here that from dev, we come back down to our local machine. And so I'm very big on the idea of the single source, the authoritative source for our schema being in source code, right? But we also have to start thinking about a single authoritative source for our data, right? And so for me, in this case here, that's very early in the pipeline, it's the development server. I should be able to go and know that that's going to have reliable data for me, and also in conjunction with whatever scripts I have to add any additional data, or whatever migrations I've had that I've done as I built my database over time. Okay. And so the goal is to use the same data. That's the bottom line, all the way through your release pipeline. And so I put an asterisk there to say that that is with some exception, right? Probably don't want to have test users in your production database. There's obviously transactions that are going to occur as you're testing and you're developing, and that stuff, I mean, it shouldn't make its way up there, but you don't want to add like junk. You don't want to release junk, right? So that's what I talk about when I say there's exceptions to that. So you talk about that, okay. All right, so now this is great because this is a way of doing it, right? And this is what's been done for many years. Now, one thing, mind you, that this can be a little slow if the database is big. And so you're now dependent upon the pipes at your company and, the size, the bandwidth that they have available to them in order to move these files. But when we talk about doing this in the cloud now, it's like, well, how do we do that? It changes. It's not the same, right? How many people here are familiar with Azure SQL Server? Okay. And so, Charles, how's your experience been with that?
I love it. Actually migrated from
Now, is that SQL Server, is that running on a VM or is it at the actual?
no, it's the actual.
Okay. And have you had any limitations or things you found yourself you couldn't do?
Yeah, so what we do is, if we're approaching some performance issues, we'll use other types of repositories. Credit cache, or in cases we use Docker to get more protection. Past, we also use the table storage.
Good. And yeah, and actually what we're going to talk about, not necessarily table storage, but storage containers.
Yeah, just different repositories.
Right, and that's the thing, guys, is just that there is a lot of options and there's a lot of ways for you to do things, but they don't quite fit the traditional way of doing things that we used to, the way we used to do things. So, if we were doing it in a traditional way, it seems pretty straightforward. But if you have your data in Azure, then you can't quite manage your data the same way. Conceptually, yes, but there is a lot of nuance to that. So we're going to cover that. So let's take a look at that, how we would do that. So before we get into it, let's talk about Azure SQL databases and the differences between this service and your traditional SQL database. So the Azure SQL database service is a general purpose relational database. It shares the same code as the SQL Server database engine and has almost all of the core functionality, right? So notice I said almost. There is some product placement that Microsoft has done, I think probably more for them to enable a good service and experience, but it seems like, oh, how convenient is that, right? It's things that are going to keep you using the cloud. But on the really good parts of that is that you get global scalability, high availability. You can scale up just by dragging a slider on the screen. And so since it's actually a platform as a service, you get most of the capabilities of the SQL Server database engine without the overhead, right? Because you don't have to patch it, you don't have to upgrade it. It's there, they take care of all that for you. It can be, yes, yeah, and sometimes you have to make those decisions. If it's more cost effective to actually have those databases and put them in some kind of elastic pool and share the resources there, or do you need something like a VM because you have to leverage, the features of the full-blown SQL Server, and we'll talk about that here shortly.
And they're getting better with their pricing tiers, right?
What's that?
They're getting better with their pricing tiers.
There's a lot available.
Yeah.
And there is some nuance with that too. I mean, you have to do some research up front. I mean, very light, but the problem is traversing between service tiers. You can't go, once you're up at a certain point, you can't do it. So you're gonna have to probably spin up. Yeah. So you run into those kind of things all the time.
Yeah, you need to do some really serious scale testing to see exactly how many DTUs you really need for acceptable response time.
Right, that's a good point. So, for example, right now we're working on standing up a performance test environment, and so because a lot of people are learning about Azure, it doesn't dawn upon them like, hey, this scenario that you're trying to do performance testing on, you're using shared resources. So you're not really getting what you think out of that kind of testing.
You have to create your whole environment.
Right, recreate your whole environment. Right, and so that's good, but then some people are like, oh, well, aren't we just testing Azure then at that point? Because Azure should like auto scale, right? It can, right? But what you're actually then testing for is, I mean, there's more to it than that, but essentially then is, are you right sizing your service tiers for your product, right? And that's what, you know, that kind of environment will give you.
So what we found when we were doing the performance test, we found one of the web apps or the app services is not able to scale out. In other words, use all the instances. You can see that by the charts and that.
Right, yeah, absolutely. Application insights, I guess you use.
No, not application insight. Very simple and easy to use charts. So if you just click on the web service, then
Oh, are you talking about the ones that are just there when you actually go to the app service?
Like right hand side, hit that dashboard.
You don't even necessarily have to get as fancy as App Insights. 'Cause they give you pretty good like response time and all that kind of stuff right there on the right there on the chart.
You can see the
And you can set warnings and all that kind of stuff.
You can do it by instant. You can also see the memory. You can do that by instance as well. And so it's a real giveaway when you see one going way out of whack, really high, and then the other three are low.
So are you talking about the web graphs
Yes.
for like response time? Because there's also the charts that will show you how many DTUs are being consumed at any point in time.
Yeah, there's that too. For
Yeah.
databases. But I was looking at a lot of different things. This database, each of the actual service bus.
Yeah, you can even go into the SEM and get really detailed.
And by the way, DTUs, data transaction unit, I think, what is it? If you guys aren't familiar with that, it's just
transfer.
or data transfer units. It's a combined metric, right, for computing power, memory, and one other thing. And so that allows you to
I/O.
to gauge the performance of your resource.
And a little bit of smoke and mirrors, I believe.
Oh, I'm sure it would. There is that. All right, so limitations, right? We did say that there are some limitations. So because it's Azure SQL Server is platform as a service, you cannot create backups manually, right? The cloud, Azure takes care of that for you.
Point in time restore.
You can do a point in time restore, but you can't. So remember when we talked about the traditional model, creating that backup, sending it off to a file share?
I can't make a .BAK file.
Yeah, you can't do that.
You get CPA.
You can export.
You can also clone it.
When you say export,
I didn't hear the joke.
when you say export, you mean exporting a table or the entire database?
So exporting a data tier, it's called a backpack. It's a little different. It's more of it's supposed to be a universal type of
Okay. Interchange?
backup, yeah. Okay, so you can't create backups, and you can't schedule jobs either, right? Because they have removed the SQL Server Job Manager, SQL Server Agent from the Azure SQL database. And so why is that? That's a really powerful tool in itself, right? And so we rely on these things. So we talk about maybe like doing a nightly backup, or even, okay, fine, we can export, but I want to schedule this somehow. Well, you can't do it with that. And the reason why, as I understand, and actually that link there is a blog post by a gentleman that touched on it. And not that Microsoft deemed that it was being abused, but that essentially was an add-on to the SQL Server database engine. And it is quite often misused. I mean, there's a lot of stuff going on, and people write full-blown programs and things like that. And so for the platform as a service, it wasn't necessary, so they didn't provide that capability there.
What I found when I was moving from the VM to Azure was that the things that I had to take out were just bad practice. So examples where there were more than one database, people were doing queries across databases. That. And then the other thing that was really weird was we were doing geocoding in the database. So we just change that and put it in the code, the database. So it removed bad practices.
Right, yeah, that's good.
Geocoding
Good
of
example.
the database
Yeah, it was
manager
terrible.
is
I never saw anything like
a
that
headache.
before.
But still.
Yeah, so if you guys want a more detailed explanation, Gavin Payne is the gentleman, and that's the link to his blog post there.
Does this also include SSIS packages as well? How does-
Yeah, you can't do not from a SQL Azure database. Yeah.
Well, but that's where like Redis cache and the data bus and stuff
All
like
the other
that.
things come into play, right?
Exactly. Yeah.
Um,
It's just a different way of doing it.
Right.
Similar.
So what does this have to do with helping us avoid shared databases for our development work? Well, if we can't create backups with Azure SQL Server, then how do we get a backup to restore somewhere else, right? What options do we have then to do that? Because that's kind of, as I started this talk, the whole idea was that we're going to have this known state somewhere where we can just go and grab it and spin up a fresh database, right? Do our work in isolation. And if you can't do that with Azure SQL Server, then how do you do it? So an approach that we can take is to export a backpack to blob storage, right? And then take that backpack and import that somewhere else. So if you can't move those things. Well, that is the way that you would move them between subscriptions. If you were in the same subscription, then you can just copy. You don't necessarily have to do an import. But for most things, being able to move across subscriptions or to another machine, that storage becomes very useful. And so, just one thing is, you create this backpack, but you also have to do something. You have to set up a service principal in order to connect to the storage, right? So now there's these other things that you have to get set up in order to enable this. All right, so what's the alternative then for the SQL Server agent? Azure Automation. All right, so Azure offers two kinds of ways to schedule tasks. They have a scheduler service, which we're not going to look at here. The main thing to know is that that scheduling service can only invoke code. Like, it can't handle workloads, or you don't write code to it. It could just make calls primarily through APIs is the way they do it, right? So if you need to set something off, you schedule it, and it'll go and invoke that thing, and that's it. The automation service, on the other hand, that can actually handle workloads. It can schedule on top of that and create jobs. And so the automation service, it's the primary tool for scheduling any other task that you would need to do. It runs, or it uses runbooks to manage, schedule, and define its jobs. And so when we talk about runbooks, there's three types of runbooks. There's PowerShell, Python, and graphical. The graphical one is, what was that one language? I think it's still around where you can do
Sketch.
Sketch is not the one I'm thinking of. Anyway, but there's a GUI way for you to create these runbooks. But the bottom line is that this is all based off of PowerShell. Right? It leverages PowerShell. It includes PowerShell workflows. So the workflows, if you want to have some kind of long-running, persistent job that runs even after a machine shuts down or comes back up, that's what you would want to use that for. So the best tools, by the way, for managing these scripts is either going to be the Azure portal or PowerShell ISE on your machine, which is the PowerShell tool for doing scripts. The online is a little quirky. Sometimes certain keyboard shortcuts don't work, or the screen will jump depending on what keyboard strokes you do. So it's good to know that. So, like I said, you can use PowerShell SE provided that you import the necessary modules that you need in order to run those things. So you have to be mindful of that. And there is an Azure automation add-on that you can install that pretty much gives you the same capabilities that you would on the portal, where you're actually signing into it and don't have to use a service principal to do stuff necessarily in your code. All right, so both options allow you to test your runbooks, and they actually have an examples run gallery where you can go in there and get examples to get you going really quickly on some of these things. But just note the differences between PowerShell script and the workflows, because you'll see both in those examples, and if you're not familiar with what you're working with, then you might start seeing something maybe not work, then you would know why. Or that'll help you to know why. All right, so now we're ready to import our shared database, right? Not so fast. Let's talk about some gotchas. All right, so in order to import our shared database, we're going to leverage several PowerShell commandlets to create the scripts necessary to import the database. So these commandlets are available to us in the portal and in PowerShell ISE, assuming that you've installed them. If you notice that a commandlet is missing, because a lot of times you're going to, like most of us, right, we don't carry big libraries of books anymore. We just search the internet for answers or how to do things. And you'll run into the PowerShell documentation. You'll see a commandlet there that says, oh, use this, and here's the switches for it. You know, this is all the data that you need to use this commandlet. But then you're in the portal, and you don't, screenshot of it, but you don't see the commandlet available for you to use. Well, it just so happens that the Azure automation tool also needs to be updated periodically with the newest versions of the PowerShell modules. And so you can either get those from the PowerShell gallery, clicking on this button, and it'll update, it'll prompt you to connect and it'll update, or you can do it here by clicking on, and that's not the right screenshot, but if you come down here, there's a place that you can update all your modules by just doing a click of a button. Okay, so once you've updated your modules, you're ready to begin automating the import of your database. So the first thing we need to do is to verify authentication with the Run As account, right? So this is created when you actually set up the Azure automation. So this is a service principal, or think of it as a service account from the Azure portal. So it'll automatically create this, like I said, when you're standing up the Azure automation service, and it'll assign a default of a contributor role. So there's different roles that it can have. Again, this is there to allow you to do things, give you permissions to get you up and running. So this also provides a standardized way for your scripts to execute your code. So you will have to do that all the time. So I recommend that you create a runbook, right, with that task, and that you save that, and then what you can do is, as you're building these scripts, you can use the runbooks that are in your account and add those in there by one line. Very simple. All right, so now we can import our database, and so the command that we would use for that is, that's hard to see, huh? I'm running. Anybody on a Mac on?
Are you using a Mac? That's what you get for using a Mac.
Maybe did you beat me to it and say wrong user group?
That's well, I was going to use my Windows VM, but I was having problems with that. So anyway,
on Mac.
This is hard to see, but this is the script for importing the database. And so, like I said, you have some information in that you have to fill out. The salient points here is that up at the top there, I'm creating a credentials object right? And that's necessary for you to connect to the storage. And so you have to create that. That's another common one that you will do often. And then a lot of these settings here, the documentation doesn't say it, but you have to be pretty much exact. For example, the max database size. That's one that you think you can just go and look at a chart and say, oh, I'm going to set it to this, but it has to be in kilobytes, which doesn't tell you, and it has to be the exact measurement, or else it can potentially result in your database being orphaned, and then you got to do a support ticket for them to clean that up. So there's a lot of nuance there. Be sure that when you're filling those things out, that you're being very accurate with those. Talk about the credential object, the database max size, kilobytes. The addition and the service objective name must also line up with the appropriate service level as well. So this is information here that's in here as well. Service name, service objective. So it says like S0, standard. Those all have to be accurate and of the right type. Okay, so what if I need to perform some additional functions, such as assigning the database to a resource group, making data, masking data, or running T-SQL to make changes, like to the database, right? Like maybe I want to update some columns or something like that. You can do these. There are several other commands you can use. One of them is to set the Azure SQL database, and so that'll allow you to do things after you've imported it. Let's say you want to put it in an elastic pool, which is a service that allows you to share the resources among several databases or database servers. Yeah, I think it's the databases that are assigned to elastic. Okay, so some of those other useful commandlets are the copy database, which I said works if you're within a subscription, right? Saves you that step of having to import. The remove SQL database. All right, so there's a typo there. That set should be another commandlet, but the database set, the remove one is important because with most things, anything that you're going to create, you either need to check the presence of it first and delete it, right? You can't just add things and expect that it's going to be there, right? So those are things also to be mindful of because it's not always clear when that's the case. So just use that as a rule of thumb. Hey, if there's something that I'm going to create something new and it already exists, I should probably check the presence of it or just delete it and create the new one. There's actually one for masking specifically. And by the way, a lot of these commandlets, you can do this in the portal with the GUI and the mouse to learn how to use it, or at least to know what the effects are, and then you can automate them. So that's always something too I recommend is do it first with some throwaway name, a temporary name, so that because there's sometimes when you name things, you can't get that name back, right? And so that's a good habit to build as well. The system data SQL client, that's something that you use within PowerShell, which allows you to make connections and basically execute commands. So if you want to run an update or some kind of query or something like that, you can do that with those. All right, moving on. So Azure SQL Server virtual machines. All right, so the virtual machines enable you to use a full version of SQL Server in the cloud, okay? Without having to manage on-premises hardware, you can automate updates, backups to blob storage, right? The typical things that you would expect.
Your
from
backup will work on
platform as a service, right? The difference here, though, is that you can manually use backups to facilitate restoring on other destinations, right? That's probably at least for the purpose of this talk, is the main point. And because the VMs are hosted in the cloud, like I said, there's other features there for ensuring high availability and such, meeting various workload demands, right? When you set this up, there is a gallery that kind of walks you through what kind of server you want to create and what edition of the database that you want. So we talked about the developer edition. That's one that you can use there, although I have seen documentation where they recommend Azure SQL database as a way of doing very quick development work, right? In this case, we're going to leverage this for having that shared database, and I'll talk about that here in a second. A shared database for the data repository, right? Not necessarily for schema. Okay, so how would we leverage the SQL Server VM to not share a database? All right, so what we want to do, the idea would be to use it much the same way as we did the Azure SQL Server, where we import the backpack, and then in this case, we're going to create a special kind of backpack to refresh our, not backpack. We're going to create a special kind of backup file to refresh our database. Right? More on that in just a bit. But first, we need to do a few things to enable this feature. So, of course, you have to store a copy of that known state somewhere, right? So we're going to use storage. So this is a screenshot of Azure Storage. And what I'm trying to show you here, guys, is this is the name, like the properties or the access keys will have the name of the resource you need, and it's going to have a key that you're going to need as well to create these scripts. Right? And if I can, here, I'll try to get a close-up of one of those scripts. Oh, one gotcha. There's two kind of storage containers that you can create. There's a blue one and a green one. I just know it as, it has to be the storage version 1. General purpose V1, right? And then you can scale that, but that's the one with the green icon. If you do it with the blue one, what we're going to talk about right now won't work. So you're welcome for that. I've spent a lot of time on that. All right, so setting up the snapshots. So in this right here, what we're doing is now we've used SSMS to log into the virtual machine, which there's some setup that you have to do for that as well. And I go to a URL, our storage container, right, that has that backpack. Or it could be a backup file. So I go there and I get that, and then it's going to ask me to authenticate into Azure. And it's going to ask for that key that I told you about earlier. Pop that key in there, you hit connect, and this ends up creating a service principal on your SQL Server to connect with Azure. All right, import it, good, get all green. All right, so now we're actually going to set up what we call file snapshots. And I'll give you more details on that here in just a second. So the first thing we want to do is create a credential, right? So we're going to script that out, and this is basically a connection, or it's an endpoint for our storage. So we want to set up a storage container for that, and that's going to be the credential that gets created on the server to connect to that storage container. And then we're either going to create a new database or take an existing one and move it over to the Azure storage, right? So here we're just taking the database files, right? The MDF, LDF, some data file. And we're going to take those and say, hey, instead of having them on my server, I want those to be located in this storage container. So then we're going to set the database to full recovery model, right? In order to, that's necessary for supporting the snapshots. All right, and then we're going to do our initial backup of our database. you need that first backup. Right? So you give it a name, again, you point it to the storage, and then from there, now I'm going to actually create my snapshot. So this to URL with file snapshots is the key there. And so basically, this code here takes it and it creates a name, and it's going to put a date to make it unique. Okay? And then afterward, I'm just going to verify the physical location of my files. Now I'm going to see that path pointing to that URL for storage. And then I'm going to check and see if I actually have any file snapshots to confirm. Setting this up and creating a new database is very easy. An existing database can sometimes be a pain because, and not to make excuses, I really did want to demo this for you guys, but one of the problems I had was I was using the Wide World Importers database, and whenever I would import it in, it kept separating out one of the files, and which I wasn't sure what it was because the name was off, and I was just spending a lot of time trying to get that working, and so that's part of this, right? So existing database, instead of doing a create, you would actually do an alter, and you're going to move the existing files. But the thing is, all those files have to be together. If you're missing one, it's not going to work. All right, so what exactly are SQL Server file snapshots? So I'm already at 8:30, and I am almost done. I got about 4 slides left. So SQL Server file snapshots is a feature of SQL Server 2016. Okay, and so since then it's been used with the newer versions on up. It uses Azure snapshots to provide nearly instantaneous backups and restores of your database files. So a file snapshot backup consists of a set of file snapshots of blobs containing the database files. So we start out with our original database files. And then they're stored in a container with the base blob, right? And so you can specify that the backup file itself be written to a URL or disk tape. Microsoft recommends, though, to use the URL. All right, so then with that, the backup is then used and it points, so the snapshots are created and then the backup points to the snapshots, right? So these are essentially, don't quote me on this as saying diffs, but they're not as big as, this in itself is going to be a full backup in itself. They're like mini backups almost. And so the file snapshot, according to Microsoft, does not copy all of the data in the database. It instead relies on the Azure storage service to snapshot the files. This makes the backup process extremely fast. So when you said earlier smoke and mirrors, that's one for me because I don't fully understand how it does that so fast, but I mean it can take a really big database and restore it very quickly.
I mean, is this an incremental backup?
Yes, that's what it is. It's an incremental backup essentially, and so these are just pointers, and so that's what makes it faster. But there's some other stuff going on there too that not necessarily been explained, at least in the documentation that I've seen.
So Rich, real quick, just to put some numbers to it, do you want to share the experience that you have with that semi-recently in terms of you had a huge database that you were backing up and you restored it in a matter of seconds, right?
Yeah, I mean, well, so one of the challenges as we're standing up a performance test environment was we have their biggest customer had like has almost like a 24 gigabyte database. I was actually testing with like a 16 gig database, and I did it the first route where I was using the backup, the backpack to get it down to the local machine, and I mean it was just taking hours. Yeah. And for me, part of the thing was I needed to be quick as a developer. I'm not going to wait around hours for that, right?
A full backup is a lot quicker.
Right, and so, well, how do we get around that? And so with snapshots, instead of doing it that way, I went to a VM. I mean, I can rebuild that database in about a minute.
Why would you
and a half.
ever not use a VM SQL Server? Is it more expensive?
I mean, I don't know what other technologies have to offer for that. I mean, I know this is something that SQL.
Why wouldn't you use a VM SQL server?
Why would you not want to use it? You know, why would you want to use the Azure SQL Server over the VM SQL Server?
Automated backup.
Okay. I
The
get
backup
that.
is just there. Less overhead, so you don't have to manage the VM. You don't have to manage any of that stuff, right? It's just there. And I do think that the
Also has your hands
the
tied.
SQL Azure PaaS, it's called Azure PaaS, is less expensive.
Okay.
And it is constantly updated. And I think that the Azure SQL VM is the commercial like you would get if you got
Requires somebody like us.
yeah. But Azure SQL will have functionality ahead of Azure, what they call on-prem, SQL on-prem. Right? So, for example, there was one project I was on where we needed the transparent data encryption, which was in Azure SQL first, by like a year and a half, right? And we also needed, or they wanted to use, what was it? Data masking, right? So column data masking, which was also in
It's very nice.
Azure SQL
What
first.
is data masking?
So let's say you're storing social security numbers,
Okay.
right? And your situation is such that you need to store the entire social,
Okay.
right?
And yes, you wanted to encrypt it, so.
Well, but in most cases, you want to just display the last 4 characters.
Mhm.
You can actually define that at the database level,
Okay, that's cool.
right?
So it'll only give you back, it'll only give you back the asterisk or whatever.
It'll only give you back whatever you decide that mask should be.
Okay, that's neat.
That's what it'll give you back. And so, I mean, is that something that you can do in your code?
Yes.
Absolutely, right? But
why not?
You
know,
can
if
do it
could-
here in your
yeah,
scripts.
That's neat.
Yep. So, yeah, thanks for that. I appreciate that. All right, so just a couple other notes here. Deleting the base blob, it will invalidate that set. Now, dropping the database does not delete the base blob. You have to do that explicitly, but it will delete the database files.
Base file is the initial full backup.
Well, that's the thing is, what you don't see, what the storage is doing, it's creating a blob. You don't, like, your eyes, I think a screenshot
That's
of that.
okay.
Your eyeballs won't, you don't see that, but that's a part of it. That's how it kind of does this.
Somewhere the incrementals have to go against an initial full
Oh,
backup.
yes.
Okay.
Yes. And so you can either do, you can restore to a particular point in time, or you can restore to a point in time between 2 snapshot sets.
Is there logging in here?
Not really. I mean, you can script that kind of stuff to get some kind of signal back.
Yeah.
And again, I apologize for not being able to see this very well. So, refreshing the database on a local machine. Again, just with the script. Now, this happens to be in a Saki script, but same thing that we've done in the other ones. Now, you don't see this code that I have up there for making the connection to the Azure account, but then I have to get a credentials object, I log in, right? And then now I'm using some code here to manage my local SQL server. And so I'm going to drop all the databases and all the existing snapshots that I have, and then I'm going to create that. Now, I have a command here to refresh. So when I refresh, it executes this code, and it essentially goes and grabs that snapshot and restores with the snapshot. And then I do some additional scripting here. So I check for the existence of something. Yeah, so I set the location, then I kick off the command to create the credential, the identity, and then I restore the database. And so you have to do some, on the local machine, again, this moving of the database files. to get back onto the container. So what's happening here is that I'm backing up, but I'm also creating snapshots that I'm going to use on my local machine on a container. So I have a convention here where I make a container based on the name of my machine, and that holds my that'll hold my snapshots for me. So then when I need to spin up a new database, I just do like a database refresh command, and it comes right back up. So this is the workflow that you end up getting as a part of this, right? So starting out, production, we export a database, just manual process, onto a storage point. And then we import that database to our SQL Server VM, right? Which also hosts a database for our dev or production or wherever happy you work. So for there, it's going to be dev. This is dev environment. And then I take that and I create a snapshot onto another storage container here, right, with my backups. Then I have a SQL script here that allows me to pull that down and essentially recreate it on my local machine, right? And then, so here then I can, on my machine, have an isolated environment and I don't have to mess with my teammates, right? And so now I can make my migrations. When I check in my code to source control, as we propagate this up, and let's say the feature gets accepted, right? Everything was good, and we merge our code to develop, we'll have, as part of our deployment, we'll update the database for dev, so now everybody has gotten my changes, right? But it's so the difference is it's in a controlled manner. It's not just willy-nilly everybody dumping stuff on the database. We're doing it as a part of our development process and our release process.
How fast is it to restore the data from the dev to the local machine?
Seconds.
Oh, in seconds too?
Yeah, seconds. Like, it's that fast.
Oh, so how can you store the snapshot?
What's that?
Do you store the snapshot?
Do you store this?
No. So how is it so fast? We calculate all the data. You talk about just the data schema or just also the data?
Right,
so you talk about just the schema also, or it's also restore the data too?
No, so yes, it is restoring the data, not just schema.
Oh.
Data as well.
Did
Right,
you
remember I said earlier,
Yeah.
they're not actually like copying or recreating all the data. It's leveraging the Azure storage blob to do some of that and the snapshots, and that's how it does it.
So when you export from production to dev, that's slow part, right? Or that's fast too?
Well, now from production to create that known state, that's not something that you're going to do often. And the reason why, or you shouldn't do often, the reason why is because another reason for having the same data, this known state, is for automation testing and regression testing, right? You should have, you should be very, you should be able to know very quickly that something's wrong because you more or less start recognizing like, oh, hey, I know that's off because this data is usually, set to this value or whatever, right? And so then you can base your automation tests off that because they're going to be running the same thing all the time, right? So now your QAs don't have to do all this regression testing either. So that's another part of this testing strategy that we want to incorporate this as well, right? That known state, so that we can have benefits in other areas, not just in our development work. All right, so in summary, we talked about the three basic rules for database work, right? So don't share databases, have that single authoritative source, and also version your database. As far as managing test data, we talked about the importance of that, right? And bad data can really slow you down. And we know the sharing databases also has its drawbacks. Can those things work? Yes, they can, but there's always some kind of risk and it ultimately affects your productivity and can create additional defects and headaches for you to manage later. So we saw how we can, like the traditional ways of managing test data, which really has not changed conceptually. The way you do it, especially with Azure, has. And so you have several tools at your disposal to do that, but it comes with a lot of nuance and a lot of gotchas. And so I covered the big ones there that got me. And so hopefully you guys found this informative and you'll be able to take this back and get off those shared databases. And if you guys have any questions too, I mean, you guys can reach me at the beginning of the slide. I have my contact information. I'm going to write that down now. Yeah, email me or hit me up on Twitter. Either way. So at this point, if you guys have any questions, fire away.
Thank you, Rich.
Thanks, guys. Appreciate it.
Thank you for joining us for the May 2018 meeting of the Houston.net Users Group. Our next meeting will be on June 14th at the Improving Houston office at 10111 Richmond Avenue. If you happen to be in Houston then, or on any second Thursday, we'd love for you to join us.